Let's suppose that the lengths of the pregnancies of a certain animal are approximately normally distributed, with a population mean of 242 days and a population standard deviation of 13 days. We're only going to look at a few of these parts of the problem. There were multiple parts, even more than this. But the first thing I want to note is that if we take a random sample of size 19, we can describe that sampling distribution of the sample mean also as a normal distribution. And it has its own mean and standard deviation. So let me scroll down to show you those. So I grabbed this snippet from our text that if a simple random sample of size n is drawn from a population with mean, mu, standard deviation, sigma, the sampling distribution of the sample mean, x bar, has the same mean as the population mean. So those two things are equal. The standard deviation, however, is a little bit different. So the standard deviation of this sample, this sampling distribution of x bar, is going to be sigma, the standard deviation of the population, divided by the square root of n, the sample size. And also noted here is that if x is normally distributed, then the sampling distribution of the sample mean, and that should say x bar right there, is also normally distributed. So coming back up to our problem, we can say that this is going to be a normal distribution that has the same mean as what was given for the population, but the standard deviation would be 13 divided by the square root of the sample size, which in this case was 19. That's probably the only formula that you really need to use in this problem. Everything else from here on down, you want to rely on the calculator's normal CDF function. So let's look at the other parts. For instance, in part C, what is the probability that a random sample of 19 pregnancies has a mean gestation period of 237 days or less? Because this is the sample distribution of x bar is also normally distributed, we can treat this problem as another normal CDF type problem where we're calculating the area under the normal curve. This time, however, with the mean 242 and the standard deviation 2.9824. So when we use normal CDF in the calculator, it will do that for us without requiring the use of the tables or finding z-scores or anything like that. It does need a lowest value, and since we're saying 237 days or less, the absolute lowest number that the calculator will accept is this value, negative 1E99. You place a comma. Then you put the upper bound, and the upper bound would be up to 237 days. Next comes the mean of the distribution and the standard deviation. And this is what we're going to type in our calculator. So to find this, let me move this over some here, in our calculator, we go to second vars, short for variables, but right here above that it says distribution. So this is a distribution that we're looking at. We're looking at the normal distribution, specifically the cumulative density function. So we're adding up this area under the curve. We can think of it like that. Usually by default, this is going to be your lower value anyway, but if you had to type it in, I want to show you where you can find those keys. So here, of course, -1, but the E is above the comma in blue. So it'd be second and comma to access that E. 99, and then a comma, I'm sorry, not a comma. Come down to upper, and you want to use 237. For the mean, we have 242, but the standard deviation of this sampling distribution of x bar, what we just calculated, is now 2.9824. You click enter for paste. It pastes that in there for you on the home screen. You click enter to run it. And this is that probability. Now you'll notice that's slightly different than the probability that was accepted here. And that's because in MyLab, it will accept either the calculator's computation or the computation that you would get with the z-tables. However, notice how much quicker that is. You can do many more problems like this so much faster than having to go through that table so many times. Okay, so I'm just moving that out of the way. What's up next is we have interpret this probability. So the best choice here is that if 100 independent random samples of size 19 pregnancies were obtained from this population, we would expect this value times 100, which is approximately 5 samples, to have a sample mean of 237 days or less. And through all of these parts, you're kind of asked to pick this, what's the best way to interpret the probability. So you're going to do something similar each time there. So let's go through at least one more of these. This one is, what is the probability that a random sample of 33 pregnancies has a mean gestation period of 237 days or less? Okay, so we're really looking at the probability that this mean is less than 237 for this sampling distribution. When we know that the mean of the population is the same as the mean of the sampling distribution of X bar, that was 242, we'd have to calculate the new sigma because now we have a new sample size. I believe that was originally 13, so we divide that by the square root of 33. Now I could calculate this and get a decimal value, but because that's not explicitly asked for here, I want to show you also that your calculator can handle all of that notation at once. So I'm going to come back over here to the calculator. Let's do another second bars number 2. We were looking at or less type of this less than notation. So there is the lower bound just keeps going and going. The lowest possible number the calculator will accept is this. The upper bound is 237. The mean is still 242. It's sigma that's different. So I can type in 13 divided by the square root of the population, or sorry, the sample size, and not even calculate that. The calculator will take care of all of that for me. Press enter to paste, press enter to compute, and we get 0.0136. So same thing here as if we were using the table.